Hello, guys. Happy third quarter. We are going to go ahead and have an asynchronous lesson today because I had a little knee surgery earlier this week, and it's just easier for me to record a couple videos and get these to you. Plus, this is a lesson continuing derivatives from last week, so I think you should be pretty good to go. The quizzes were really good, FYI, and we're going to continue looking at derivatives, excuse me, and then we're going to start looking at integrals. So that is the opposite of a derivative. But today we're going to find expressions for the derivative. All right. And what that means is if you have a function in the form of f of x equals x to the n, there is a rule for finding the derivative. Here's the rule. Oops, helps if I use a highlighter and not a pen. Here's the rule, okay? Basically, what you do is you take your exponent, bring it to the front, so you're bringing your n to the front, and then subtracting your power by 1. And I'll show you what that looks like. In this example right here, given f of x equals x cubed, find f prime of x. So instead of looking at graphs for this or looking at the way we would draw it, we're just going to find the derivative. So f prime of x, you would just take the 3, bring it to the front, and then subtract your power of 3 by 1. So your derivative would just be 3x squared. Okay, so the derivative of x cubed is just 3x squared. A curve has an equation y equals x to the negative fourth, so dy dx, or another way to write y prime or f prime of x, depending on what our function is, negative 4x, and then again, negative 4 minus 1. Be careful with this, because with negative exponents, you're still subtracting 1. So you would have negative 4x to the negative fifth. That would be your derivative. All right, so careful with that. Here's the rule in this red box, just saying that. You can do it with any variable. Find the derivative. So f prime of t equals, bring the 5 to the front, so you would have 5 times 2 t to the 5 minus 1. So you get 10 t to the fourth. So you just multiply whatever is in front and then subtract by a power of 1. Okay, so the same process every single time. Bring the exponent to the front, multiply it by whatever's there, subtract the exponent by 1. Here, we're going to rewrite y as 6x to the negative 2. Then we can find y prime. We're going to bring the negative 2 to the front, multiply it by 6, and then x to the negative 2 minus 1. So we end up with negative 12x to the negative 3. Or, if you really wanted to, you could write that as negative 12 over x cubed. But you don't need to. Same thing, however. Okay? Find dy dx for 7x minus 2. Okay, so something we might want to consider just looking at this, because now we have a constant. This is 7x to the first power minus 2x to the no powers. We have no x. X to the 0 is 1. So if we look to take our derivative here, f prime of x, we would have 7 times, basically there's an imaginary 1 there that we're going to bring down, x to the 1 minus 1 minus 2 times 0, x to the 0 minus 1. Okay, because we're bringing our exponents down. So that ends up being 7x to the 0 minus 2 times 0 is 0, which just equals 7. So our derivative of a constant is 0. So it just goes away. All right, so the derivative of a constant is 0. That is something to remember. All right, so if a is a constant, find the rate of change, y equals x plus 3, x minus a with respect to a. So the first thing we're going to do is multiply this all out. X squared minus ax plus 3x minus 3a. Okay, so I'm just going to write that in, I don't know, I like descending order of my exponents and powers. Okay, so with respect to x, so y prime would be 2x plus 3 minus a. And then this is a constant, so the derivative of this is just 0. So this is my solution. Okay, with respect to x, so again, these are to the first power. So you're just bringing a 1 to the front, and then those go to the 0 power. So basically, any power that you have is just decreasing by 1. So if I have 3x, the derivative of 3x is just 3. If I have negative ax, the derivative of that is just negative a. Okay. Differentiate here. Again, we're going to rewrite f of x as x squared over 2x minus 6x over 2x. So we're going to split this in terms of a common denominator. So when we do that, we end up with 1/2 x minus 3. I'm missing a squared. No, I'm not. This is... Oh, I might have typed that problem incorrectly, but then that's all we have left. Okay, so we've got x squared over 2x minus 6x over 2x. So we end up with f of x just being 1/2 x minus 3. So our derivative is just 1/2. Because the derivative of 1/2 x is just 1/2, and then the derivative of the constant goes away. So that's all we have there. All right. Be the examiner. So you're given 6x squared minus 5x over x cubed. Find the derivative. So dy dx, if I looked at that just like we did the problem above, I would separate this into common denominators. All right, which just gives me 6 over x minus 5 over x squared. Well, we haven't taken the derivative yet, so I guess I'm going to leave this as the original function because to not be confusing, this is still what y is. And then we can rewrite y as 6x to the negative 1 minus 5x to the negative 2. So when we go to take the derivative of that, we bring down our exponent, we get negative 6x to the negative 2 plus 10x to the negative 3. That happens to match this guy right here. Okay, so negative x to the negative 2 plus 10x squared. We get that from bringing our exponent down, multiplying, and then subtracting 1 from the power. All right, find the intervals of the value of x for which the function f of x equals 5x squared minus 12x plus 3 is decreasing. All right, well, something you need to know for any question about increasing or decreasing, start by finding x prime of x. Start by finding f prime of x. Okay, so to do that, in this case, we end up with 10x minus 12. All right, so a decreasing function has a negative slope, or it is where the derivative will be less than 0. It'll be under the axis. Remember how we talked about that? So you can just say 10x minus 12 is less than 0. So 10x is less than 12 and x is less than 1.2. So anytime you want to know where a function is decreasing, it's where the derivative is less than 0 or under the axis. All right. Same thing for this question. We have if the function f prime of x equals 2x cubed minus, is the function f prime of x equals 2x cubed minus 3x increasing or decreasing at x equals 1. So this is the derivative, okay? So we're already given the derivative here. We know that f prime of x equals 2x cubed minus 3x, and we want to know what's happening at x equals 1. So we just plug in 1 because we already have the derivative, and we get 2 minus 3, which equals negative 1, which is less than 0. So we are decreasing. All right, so that is this one. All right, you have to be careful with what you're given and what you're starting with. Here are the homework problems. It's just practicing taking the derivative and finding where something is increasing or decreasing. But other than that, let me know if you have any questions with that. Reach out, send me a message if you have any questions over the weekend or you're working on this. But hopefully it's pretty straightforward. And again, the solutions, you can always check the textbook solutions that I have posted in this unit. All right, guys, I hope you have a great weekend. I'll look forward to seeing you next Wednesday. I should be pretty healed by then, and maybe we'll even be in school.